Anyone that has seen any form of media for the past 20 years knows that our country is facing rising cost energy. This is caused mainly due to the gradual decline of availability of fossil fuels. With this decline imminent, we need to look for alternative sources of energies. One such source that we should utilize to a larger extent is that of nuclear power. Nuclear power can still be a viable source of energy for this country on a massive scale. The process and facilities for creating nuclear energy is safe. It yields high amounts of energy that pays for all the construction, and it leaves little to no impact on the environment. One of the biggest comments against nuclear power is its radioactive emissions into the environment. Now, everyone has seen the tall stacks of steam coming out of nuclear reactors, and they look like they're putting tons and tons of pollutants into the air, but that just isn't true. Out of those stacks only vents out the steam, and that is created from the cooling of the core. The steam is run through a series of tests and filters that contain the radioactive elements for disposal in proper disposal facilities. Outside the small amount of radioactivity that is left in the steam when it is exhausted out of the facility, which is within the normal range of radioactive and natural elements, the biggest danger comes from the disposal of the spent fuel. Spent fuel rods are also very difficult and hazardous to dispose of. Currently, there are two different methods that are being considered for long-term disposal. One method is to contain the spent fuel rods in barrels encased in cement, which then get dropped into some of the deepest trenches in the Pacific and Atlantic Oceans. The more logical and currently used method is burning barrels in underground chambers in the Yucca Mountains. This range of mountains is one of the least geologically active places in the United States, but disposal is not the only way of affecting the environment and the people in it. It is true that nuclear power plants have the ability to be destructive. If anything, the disasters that have happened recently in Japan demonstrate that potential, but that does not mean nuclear power plants aren't safe. In 32 different countries, there is a cumulative total of 14,400 years of plant life, and only 3 major accidents have ever occurred in all of that time. In a nuclear power plant, the key to safety is the levels of redundancies that keep a reactor safe. There are multiple shields that protect the environment that also consist of multiple backup securities designed to cut out any human error, like which caused the 3 Mile Island incident. In all 3 accidents in Chernobyl, 3 Mile Island, and in the Fukushima disasters, it was human error that caused almost all of the meltdowns. In 3 Mile Island, it was people overriding safety measures to see how much the containment fields would actually hold. Chernobyl was a lack of safety measures in the initial design. They did not have enough cooling systems set in backup for when any of them faulted. And Fukushima had 3 older reactors, together with a 4th that had lost cooling due to a huge tsunami that was inadequately contained. What happened was their backup power wouldn't go on because they were covered in seawater and their generators wouldn't fire up. Another thing to look at is how much we spend on an average. Another way to look at it is how much they spend on average on safety measures. Their safety measures add up to over a quarter of the startup cost for every reactor. It's true that the upfront cost is substantial for any type of power plant. It's also true for nuclear reactors. The difference that a nuclear reactor has the capability of being cost-effective and sustainable for the long run. For a non-nuclear reactor power plant to pay its cost off, it would take at least 5 months of consistent power output for it to make up the initial cost of the plant, whereas a nuclear reactor can do the same in only 1.5 months. 1 ton of uranium can create over 40,000 kilowatt hours of energy. That's equivalent to 16,000 pounds of coal or 80,000 barrels of oil. Going along with this cost-effective trend is the cost of the fuel-to-energy ratio. For uranium, it costs about 3 cents per kilowatt hour, whereas the next leading fossil fuel is Australian coal, which can range from 2.2 cents to 4.4 cents kilowatt hour. Now, this differential is not very big between the two, but what it really means is that uranium is much more stable, and the coal will vary from time to time depending on how high quality the coal is. The other nice thing is uranium is one of the most common elements on the Earth's crust. It's as common as tin, actually, It is the 48th most common element in the Earth's crust. And with the increasing demands of oil in the world, we will soon start a descent in not being able to produce enough oil to meet the demands of our use. Hopefully this has given you some insight why a nuclear power plant can still be a viable energy source for the future. With its safe, dependable, cost-effective, and environmentally friendly source of energy, we can create a cleaner world for the future generations, along with a world they can afford to live in. And now we can try and make that world.